Welcome to Chemistry with Caroline. In this video, we're going to look at an introduction to the Keto-Enol Tautomerization. So I have drawn before us here both the keto, and that would be this one on the left, and the enol tautomers for this tautomerization. So tautomers are molecules that are in equilibrium by the migration of an atom or a group. For the Keto-Enol Tautomerization, that atom is a hydrogen atom. So this hydrogen atom right here on the keto migrates to that position on the oxygen in the enol form. So the keto and the enol are constitutional isomers. They have the same molecular formula, but a different connectivity. And they are in equilibrium with one another by the migration of that hydrogen atom. So for most systems, the equilibrium is going to lie towards the keto form. That's the favored form. The carbon-oxygen double bond, thermodynamically speaking, is more stable than the carbon-carbon double bond that we see in the enol form. And so for most systems, you'll see the keto as the predominant tautomer for that equilibrium. So keto, referring to the carbon-oxygen double bond, you could also have an aldehyde version of this. Enol, right, is ene, tells me I have a double bond, and the OL tells me that I have an alcohol. There are a few exceptions to this, so let's go to the next page and we'll look at some systems where the enol is the favored tautomer. So I have an example here where we have a cyclic system that has a carbonyl coming off of it and a couple of double bonds in it. So on the left here, I would have my keto form, right? And remember, this is the migration of a group, specifically a hydrogen atom for this tautomerization. So I've drawn our hydrogen atom in red here. So that would migrate onto the oxygen for the enol form. So this is our enol form, and here we have our hydrogen migration. Now what you'll notice is that in the enol form, I have an aromatic ring. So I have a benzene ring. Aromatic rings are really stable. And so the stabilizing formation of that aromatic ring is going to drive that equilibrium towards the enol form. On the keto here, I have a non-aromatic ring because I have a sp3 hybridized carbon right here that has another hydrogen on it too, and so that ring doesn't have the stability provided by an aromatic system. Another example of a system where an appreciable amount of the enol tautomer would form is these beta diketones. So for a ketone, you have like the reference carbon, that's the carbonyl carbon, and then we call the next door neighbor position the alpha position, and then the one next to that would be the beta position. So this is called a beta diketone. The second ketone is at the beta position di because there's two of them. That's the keto form. And then on the right, I have drawn the enol form. Now in this particular setup here, the enol form has conjugation because you've got the carbonyl carbon, and then that's adjacent now to the carbon-carbon double bond that the enol forms. So this system is conjugated, and that's going to offer a lot of stability to it. The other thing is because of the proximity of those two oxygen atoms to one another, there's actually hydrogen bonding that occurs between the carbonyl oxygen and the hydrogen that's on the alcohol next door. And so this hydrogen bonding is a stabilizing force as well. That's a very strong intermolecular force. It has a lot to do with why alcohols have such high boiling points. The molecules are very attracted to one another because of that intermolecular force. So these two factors stabilize the enol form a lot more than we might see in like a typical keto-enol tautomerization. So these exceptions, when the enol is favored or in a significant amount in equilibrium, typically come about because the formation of the enol makes it so that that molecule is stabilized in some way by aromaticity or conjugation or a favorable intermolecular force that forms as a result of that formation of the enol. So this has been a look at the Keto-Enol Tautomerization. If you found this video helpful, please like, subscribe, and share with your friends. Thanks.